Have you guys ever heard of naked mole rats? I first heard about this story at work and it grabbed my attention for a couple of reasons. One, because I have an interest in longevity science, and two, because naked mole rats freak me out. If you haven't heard of them, the naked mole rat is a small, hairless looking rodent, and I say hairless looking because technically they're mammals, they probably do have some wispy or fine hairs, but they do at least appear to be hairless, hence the name. And they can be rather unsettling to look at. I perhaps somewhat unfairly have tended to think of them as one of the ugliest creatures alive. Their virtually hairless faces and bodies are covered in pink, wrinkly skin, and they have the tiny, beady eyes and nearly absent ears of a mole, plus the usual long, curving yellow front teeth of a rodent on full display, unconcealed by any facial fur. Definitely not something most people would want to glance at while eating, although I will say I think I'm starting to warm up to them, kind of like with Matt Dillahunty. Maybe in part because of the knowledge, that they may possibly be able to help us live longer someday. Sadly, most rodents have pitifully short lifespans. In the wild, a mouse, for instance, might only live on average in between 6 to 18 months. Put that in the life is brutal file. Or a pet or indoor mouse might live around a couple of years if they're lucky. The naked mole rat, on the other hand, can live upwards of 30 or even 40 years. And quickly for context, that Matt Dillahunty reference was a callback to the last segment. If you're watching this on YouTube, this is just an excerpt from the full-length show. But to get back on track, scientists and researchers have long been interested in the naked mole rat because of its impressive lifespan and its resistance to disease. As I alluded earlier, a news story recently broke regarding how scientists managed to successfully transfer a longevity gene from a naked mole rat into a mouse or mice, plural, and it lengthened the mice's median lifespan by about 4.4%, I think. A roughly 4% increase might not sound like much, but when you're talking about lifespan, especially in a creature as short-lived as a mouse, it's probably still significant. But now they're hoping that this will eventually lead to medical advancements or breakthroughs that could increase lifespan and disease resistance in humans. I'll read a bit from this article. And so this is from the official EDU site of Rochester University. And it's entitled Longevity Gene from Naked Mole Rats Extends Lifespan of Mice. And it's dated August 23rd, so not that recent, but not that long ago either. And there's a quote here underneath a lovely image of a naked mole rat. It took us 10 years from the discovery of HMWHA in the naked mole rat to showing that HMWHA improves health in mice, says Rochester biologist Vera, I think it's Gorbanova, but she continues, our next goal is to transfer this benefit to humans. In a groundbreaking endeavor, researchers at the University of Rochester have successfully transferred a longevity gene from naked mole rats to mice, resulting in improved health and an extension of the mouse's lifespan. Naked mole rats, known for their long lifespans and exceptional resistance to age-related diseases, have long captured the attention of the scientific community. By introducing a specific gene responsible for enhanced cellular repair and protection into mice, the Rochester researchers have opened exciting possibilities for unlocking the secrets of aging and extending human lifespan. And here's another quote. Our study provides a proof of principle that unique longevity mechanisms that evolved in long-lived mammalian species can be exported to improve the lifespans of other mammals, says Vera Gorbanova, the Doris Johns Cherry Professor of Biology and Medicine at Rochester. Gorbanova, along with Andrei Selenov, I think it is, a professor of biology, and their colleagues, report in a study published in Nature that they successfully transferred a gene responsible for making high molecular weight hyaluronic acid, HMWHA, from a naked mole rat to mice. This led to improved health and an approximate 4.4% increase in median lifespan for the mice. And then there's a section entitled A Unique Mechanism for Cancer Resistance. Naked mole rats are mouse-sized rodents that have exceptional longevity for rodents of their size. They can live up to 41 years, nearly 10 times as long as similar-sized rodents. Unlike many other species, naked mole rats do not often contract diseases, including neurodegeneration, cardiovascular disease, arthritis, and cancer as they age. Gorbanova and Selenov have devoted decades of research to understanding the unique mechanisms that naked mole rats use to protect themselves against aging and diseases. The researchers previously discovered that HMWHA is one mechanism responsible for naked mole rats' unusual resistance to cancer. Compared to mice and humans, naked mole rats have about 10 times more HMWHA in their bodies. When the researchers removed HMWHA from naked mole rat cells, the cells were more likely to form tumors. Gorbanova, Selenov, and their colleagues wanted to see if the positive effects of HMWHA could also be reproduced in other animals. The team genetically modified a mouse model to produce the naked mole rat version of the hyaluronan synthase 2 gene, which is the gene responsible for making a protein that produces HMWHA. While all mammals have the hyaluronan synthase 2 gene, the naked mole rat version seems to be enhanced to drive stronger gene expression. The researchers found that the mice that had the naked mole rat version of the gene had better protection against both spontaneous tumors and chemically induced skin cancer. The mice also had improved overall health and lived longer compared to regular mice. As the mice with the naked mole rat version of the gene aged, they had less inflammation in different parts of their bodies, inflammation being a hallmark of aging, and maintained a healthier gut. And I'll jump down a bit, a fountain of youth for humans, ? The findings open new possibilities for exploring how HMWHA could also be used to improve lifespan and reduce inflammation-related diseases in humans. And here's another quote. It took us 10 years from the discovery of HMWHA in the naked mole rat to showing that HMWHA improves health in mice. Our next goal is to transfer this benefit to humans. And here's another quote by Selenov. The last quote was from Gorbanova. We already have identified molecules that slow down hyaluronan degradation and are testing them in preclinical trials, Selenov says. We hope that our findings will provide the first, but not the last, example of how longevity adaptations from long-lived species can be adapted to benefit human longevity and health. And so as someone who is already interested in longevity science, I find this very interesting. And I do hope that science will make inroads into, if not thwarting or defeating age-related disease and maybe even the process of aging itself, that we can at least eventually ease or lessen the deterioration that accompanies age-related disease or age-related diseases.